cuties, hope you're having a good day. Let's look into a new video, and today we are going to look into a new topic, that is prime factorization. This prime factorization is used if you want to find the prime factors of a particular number. You can refer my previous videos to know more about what are factors, what are multiples, what are prime numbers, and what are prime factors. And you can also refer the divisibility rules to know how to find whether a number is a factor of another number or not. Now we are going to use all those informations in order to do prime factorization of a particular number. Let's see what is this prime factorization. So I have written here a small question. Find prime factors of 75, which means we are going to split 75 into its factors, and that too specifically prime factors, which means the numbers which do not have any other factors except itself and the number 1. So we have different methods to do prime factorization, but I am going to start with the most easy method, that is factor tree method. Yes, we are going to draw a tree. You might have seen family trees in pictures and all. Same way, let's draw a family tree for the number 75. So let's see how we are going to do that. So we'll start by writing 75 inside a square box. Now remember, we are going to do it just like a family tree. So we are going to find two factors for 75. So when I say two factors, remember it will be better if you start with a prime number. If possible, we can start with a prime number. So look at the number 75. Here, let me use the divisibility rule of 5. If you remember the rule, if the last digit is a 5 or a 0, this number is divisible by 5. Which means I can happily say that 5 is one of my factors. So let me write 5 as one of the factor, just like one of the parent. Now since 5 is a prime number, instead of a square, I am going to put a circle around it, just to make it clear that it's a prime number. Now let's divide 75 divided by 5. So if you check the multiplication table of 5, you'll see that 5 multiplied by 15 is equal to 75. So 15 is the second factor. But did you notice that I put a square around 15? Because 15 is not a prime number. It can be split more and again into further prime numbers. So this time now let's go and split 15. So 15, again think, which factor can be used for 15? Why don't we use the same rule? 15, again the last digit is 5, which means it's divisible by 5 itself. So let me again put one of the factors, 5 itself, and 5 being a prime number, inside the circle. So 15 divided by 5, we know the answer, it's 3. So let me write the other factor as 3. And since 3 is a prime number, let me put it inside the circle. Now you just take the numbers inside the circle. Our main number 75 will be equal to this first prime number multiplied by this guy over here multiplied by the last one over here. 5 multiplied by 5 is 25, and 25 multiplied by 3, you can actually check it, it's 75. And this is how we are splitting a number into its prime factors, or in other words, we are representing 75 as the product of. So what's product? Product means we are writing the answer as a multiplication. So product of different prime numbers. So I hope this was clear. Let's see one more example. The second example I have taken is 224. Find prime factors of 224. Let's see how to do the same prime factorization using the factor tree method for this 3-digit number. So I have already written the steps here, but don't worry, let's look into each and every step one by one. Starting with writing 224 in a small box. Now let's revise the divisibility rule of 2 here. The last digit of 224 is an even number, so definitely it's going to be easily divisible with the number 2. And 2 being a prime number, I wrote a factor 2 inside a circle. you just divide and see 224 divided by 2, you will get the answer as 112, which is again not a prime number. So I have put it inside a box. Let's again find the next factor. Once again, the last digit is even. So no need to worry. Let's take the same 2 as one of the factors. So 102 divided by 2. 2 inside the circle again because it's a prime number. And the answer that we'll get is 56. 112 divided by 2 equal to 56. 56 is inside the box again because it's not a prime number. Let us again find the next factor. Same rule is applicable. The last digit is even now. So again the factor is 2. Now again 2 inside the circle because it's prime. 56 divided by 2, you will get 28. Again the last digit is an even number. So one of the factors can be 2 again. So 28 divided by 2, you will get 14. 14 also last digit is even. So one of the factor is still 2. So 14 divided by 2, you will get 7, which is a prime number, and hence I have put it inside a circle. Now if you just check these things, 2, 2, 2, 2, 2 and 2, you can write that the number 224 is equal to 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2 and multiplied by 7. All the prime numbers or the all prime factors multiplied together, you can actually check, it will be 224. And this is how we represent a number as the product of its prime factors. So I hope this video was informative and this factor tree method is now easy for you. So please like my video, share and subscribe. Let's see in the next video with another method of prime factorization.